So example number 3, a ball rolled up a ramp after 3.25 seconds reaches its maximum displacement. It then rolled down back to the point of release. What's the initial velocity? What's the acceleration of the ball? Now a little picture actually helps quite a bit, and we'll get to the solution right now. So in this case, what we're doing is pushing a ball up a ramp. We have an initial velocity at the beginning, which is unknown. At the top, though, at its highest point, we know that the final velocity is 0. And that's one of the keys to this. We also know that the distance that it traveled was 8.15 meters, and the time to go from the bottom to the top was 3.25 seconds. So we know lots of information. Initial velocity is unknown. Final velocity is 0. Time of flight or time of travel is 3.25 seconds. And the displacement during that time is 8.15 meters. And so, using our 4 kinematic expressions, we look for an equation or formula that does not have what? Well, it doesn't have A. And that, of course, is d is equal to Vf plus Vi over 2 times t. And we have to solve for Vi. So to do that, we go 2d over t. What I did was multiply both sides by 2, divide both sides by t, and I end up with Vf plus Vi. Then, to solve for Vi, I go 2d over t minus Vf. Now, it doesn't really matter much right now because Vf is 0 anyways, but we get Vi. And so 2 times 8.15 meters divided by the time, 3.25 seconds minus 0 is equal to Vi. And of course our solution is 5.015 meters per second. And of course we'd round that to 5.02 meters per second. All right, and that was the initial velocity. Now what was the acceleration? Well, we could go up to the top here and say, since the initial velocity was unknown, or in this case the initial velocity now we know was 5.015 meters per second. The distance was 8.15 meters. The time was 3.25 seconds, and we want to know what the acceleration was. We might want to look at using this equation where A is equal to, and we of course also know that Vf is equal to 0. We might want to look at the equation A is equal to Vf minus Vi over t. Now most of the solutions require a knowledge of Vi. And so we'll use the Vi that we solved for in the first problem. And so we get 0 minus 5.015 divided by the time, which is 3.25 seconds. And what we get is A is equal to, all right, 5.015 negative divided by 3.25, and we get 1.543. All right, we get 1.543 meters per second squared. And that would be negative because, of course, if up the ramp is positive, then coming down the ramp is negative, and that's what acceleration is doing. It's slowing the object down. So I would say acceleration is negative 1.54 meters per second squared. Now, it's a little bit different than what I have on the answer key, so we'll take this one as the facts. It looks like the solution on the other page is incorrect.